Good afternoon, ma'am.
Good afternoon.
Okay, we will start the class. All are able to hear and see the screen that is presented now.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, who has pressed the recorded session? Who pressed the record button among you? Whoever pressed the record button, you put it in your GCR. Okay, as usual. All right. So last class, what are the various transducers that we have discussed?
Ma'am, ma'am, you are the host, so it will come to you, ma'am.
Oh, if it is coming to me, I will put it in GCR. No problem.
Okay, ma'am.
Okay. Okay. So last class, what are the various transducers that we have discussed? Some of the electro-optical type of transducers have given introduction. No, one was LED and the other one was what? Photodiode and phototransistor. Okay, the remaining set of electro-optical transducers we are going to discuss today, starting with laser diode. And you people have given me example applications where we will be using this laser. Now, how this laser light differs from other types of light, they have given in this diagram. Suppose if you take the case of sun, okay, the waves that are emitted from the sun, they may be visible or they may belong to IR category or they may belong to UV category. So different types of waves are released from the sunlight whose frequency will be differing and they will not be in phase. Okay, both frequency and phase will be varying, okay, from the sunlight. Suppose if you take the case of an bulb, here also the waveforms are not in phase. As you can see, the waveforms are not in phase, but they all the waves will be of single frequency. But if you see to the special category of light that is called as laser light, what feature has been given for laser light?
Single frequency coherent.
Single frequency coherent. So all the waves that if you are seeing that is coming out from the laser, all are belonging to the same frequency. Okay, same frequency and all will be in phase. Okay, that is a specialty or special feature of a laser light, which you will be using in medical applications like correction of eye power and for other cancer treatment and so many other applications we will be using laser light applications. Okay, now you people understood how this laser light is different from other types of light, huh?
Yes, ma'am.
So how does it differ?
Ma'am, it is of single frequency and is coherent. That is
Yes,
in all phase.
laser actually is nothing but laser diode. If you call it, is nothing but a special type of pin diode only, which is capable of emitting a special light which is emitting waveforms all of same frequency and same phase. That's why they are called as coherent. Okay,
Ma'am,
coherent.
ma'am, is that the reason due to which it passes to long distance?
Long distance and all depends upon the wavelength and all. No, that is quite different from coherency. Okay.
Okay, ma'am.
Okay, so now the expansion for the term laser you need to discuss. Okay, so here they have given what is expansion for laser. So what is expansion for laser?
Light amplification by stimulated emission or radiation.
Light amplification by stimulated emission of radiation. So here you are going to use radiation only by, but you are going to control the amount of radiated light that is to be given to the application. That's why it is called as light amplification by stimulated emission of radiation. Okay, don't forget that the abbreviation laser is expanded as light amplification by stimulated emission of radiation, not by spontaneous emission, stimulated emission of radiation. And the device that is capable of emitting this laser light is similar to a PN junction diode only. It is called as a laser diode. Okay, how that happens we will be discussing now. So this is also called as a pin diode. Here you are having P layer, here you are having N layer. In between you are having what layer? What is the name of the layer that is given in green color?
Intrinsic.
Intrinsic layer. So this is also called as a pin diode. Okay, this is also called as a pin diode or a laser diode is called as. Alright. And you know how a PN diode acts. Okay, you know how a PN or normal diode acts. So here you can have two terminals. There are two terminals, one connected to the P layer and the other one connected to the N layer, via which you will be giving the input. Okay. Now, the central layer is very important. That is, the intrinsic region is very important because it will be activated and it will be kept in active region. So, if it is kept in active region, means more and more number of holes and electrons will be accumulating in this particular junction. Okay, from P, which is having major charge carriers, holes. Here it will be moving to the central layer, and here electrons will be moving to the central layer, and both will be recombining at this particular intrinsic layer, and it will be happening at a greater rate, okay, which will be emitted out from this elliptical junction. There is an elliptical junction, as you can see from the diagram, from which the laser light is emitted out. But this is a stimulated emission, not a spontaneous emission, but you need to regulate, okay, this laser output. So what they will do is, you will keep an optical lens here. All right, this will be an optical lens. So what is the use of a lens? Why do you need to have a lens at this particular point? All I've told me, there's a laser medical application. So if you want to use laser for particular application for correcting one particular part of the eye, so in that particular part of the eye only, that laser should be falling upon. Okay, so in order to do that, what do you need to have in between? Lens. Okay, so the lens will do the focusing. Whatever may be the light that is collected here, that will be focused and it will be given to that particular application. That's why you usually use an optical lens in combination with this pin diode. Okay, that is a special type of diode, light amplification by stimulated emission of radiation. It is also called as homojunction laser diode. It's nothing but a pin diode, a P-type material and an N-type material sandwiched with an intrinsic layer in between. So here via the two terminals you are going to give the input, and in the intrinsic layer you are going to activate it to an active region so that higher number of electrons and holes gets accumulated in the central layer, which will be resulting in a stimulated emission of light that is called as laser light. And this laser light will be focused by means of an optical lens, okay, onto the particular application. Now, if you see to the characteristics of the same laser diode, now you can see here at this particular point is called as threshold current, and in this axis you are having an optical power, and here you are having current. Okay, this is a characteristic curve that is drawn between current and optical power. So when the PN junction, that is pin diode, that is laser diode, is activated up to the threshold point, whenever you are increasing the input electric current, the optical power will be gradually increasing. You can see this is a gradual increase of the optical power with the increase in the current. But once this threshold value crosses, okay, this region is called as region of what emission? Normal emission. That is called as what emission?
Spontaneous emission.
Spontaneous emission. But once this threshold current value crosses out, even for a small value of increase in current, you will be able to observe how much amount of optical power Here there is a gradual increase, but if you see here at this particular portion, it's increasing to a higher degree even for a smaller change in current. This is because of what emission?
Stimulated emission.
Okay. So this is how the laser diode is very special. Okay, it's quite different from an ordinary PN diode, because in between you will be having a special intrinsic layer. That intrinsic layer will be kept in active region. So more and more number of electrons and holes will be accumulated at the junction, and there will be a stimulated emission, controlled emission, which will be coming out from the elliptical portion. And in order to focus all the waves, these are coherent waves, because the frequency and phase of all the waves will be same. So when you are going to apply that laser onto a particular application, you need to focus it properly. For that purpose, you will be also using an optical lens arrangement. So this is all about a laser diode, which is also an electro-optical transducer. Next comes your photoresistor. Okay, photoresistor is also called as what? LDR, that is light dependent resistance. Suppose if you consider, for example, a traffic light or any street lighting assembly, suppose if it is a daytime, automatically the street light should be on or off. Assume a
Off.
scenario, okay, where you are having a street lighting assembly of lights. In the daytime when sunlight is available, you want all the lights to be off or on?
Off.
Off. So in that case, when the sunlight is falling onto this photoresistor, okay, or LDR, the sunlight will be made to fall on this LDR or photoresistor sunlight. So when it falls on it, what will happen is the intensity of light is in an increased level, because of which what will happen to the resistance?
Decrease.
The resistance will be decreasing. Suppose what? Resistance will be decreasing, and on the other hand, suppose if the intensity of light is decreasing, then the resistance will be increasing. Okay, so that is how the relation between the resistance and light happens here. So now how that happens we'll discuss. So this is the circuit symbol of a photoresistor. Okay, this is circuit symbol of a photoresistor. And this is the constructional part. Okay, as usual, you will be having a semiconducting, semi-insulating substrate, and you will be having N plus and N active layer here. And suppose if you assume the light is falling upon this device, okay, that is your photoresistor. So as indicated here, the valence electron absorbs energy, that is thermal activation happens for this device. So because of which there will be thermally generated carriers, and these thermally generated carriers will go hit other covalent bonds, thereby breaking up more and more free electrons. So when there is a release of more and more free electrons, it is equivalent to what effect?
Ma'am, would you please repeat?
Suppose if you consider this is your photoresistor, you are having sunlight falling upon it. So when the sunlight falls upon it, it is nothing but a thermal action, okay, some sort of thermal action or light action. So because of this, there will be some free electrons that will be breaking up from the parent covalent bonds, and they will go hit other covalent bonds, releasing more and more free electrons. Okay. Suppose
Yes,
if
ma'am.
more and more free electrons are flowing, then it is equivalent to what effect?
Ma'am, photoresistor effect.
Free electrons, if they are flowing, means it is equivalent to flow of electrons is generally equivalent to what? I'm pointing
Electric current.
electric current. So if more and more free electrons are free to flow, then what will happen to the electric current effect?
It will increase.
Yes, it will increase. So you are going to break more and more free electrons, and as a resultant of which the current will be increasing at a larger rate. So you know by Ohm's law, if current is increasing, what will happen to the resistance?
It will decrease.
Yes, it will decrease. Okay. But on the other hand, if the light intensity is reducing, then the thermally generated free electron flow will reduce. In that case, current flow will drop down. So resistance will increase.
Increase.
Okay, so this is why it is called as, what is the name of this transducer? Photoresistor. Okay, and this is their circuit symbol, and this is the constructional feature. Okay, now where you are going to apply this photoresistor, already I told you. When you are wanting to light a street light, during daytime you want them to be off, during nighttime you want them to be on, or otherwise in your college also you are having some touch sensor. All right, so whenever people are passing through that particular way, the light will be on. When nobody is passing through that particular path, the light will be off. So that is based on thermal sensor. But so if you want to have a sensor that is to be used for controlling the turn on and turn off of a street light, you can use a photoresistor, or what is the other name for the photoresistor? LDR. What is LDR? Expansion for LDR. LDR, light
Dependent resistor.
dependent resistor. It is also called as LDR, light dependent resistor. Why it's called so is because depending upon the intensity of light that falls on it, it controls its current flow as well as resistance. That is why it's called as light dependent resistor. This is also used for solar cell, as I already told you description regarding the application. Now we have discussed photoresistor. Next we will discuss about photoconductive cell. Earlier device was photoresistor. Now it is photoconductive cell. So this is the circuit symbol for your photoconductive cell. And if you see to the construction, again you will be having an insulating substrate, then you will be having a metallic electrode and photoconductive material, and these two terminal contacts will be connecting it to the application that you want to activate it. This is the one of the application of that photoconductive cell, where you will be activating a relay. So what is a relay actually? Relay is one sort of protection device which will be conveying the circuit to be made or broke open, then that message will be relayed by this relay assembly, the magnetic relay assembly. Okay, so this is your photoconductive cell that is to activate this relay. All right, so depending upon the light intensity that is falling on this photoconductive cell, the resistance will vary linearly, and accordingly this relay will be either activated or it will be remaining idle. Okay, and if you see to the characteristics here, this is your characteristics of photoconductive cell. Now this is drawn between illumination and resistance. So this variation is a linear variation. Okay, with respect to the light intensity, this is a linear variation that you are observing. So when the illumination is very low, okay, when it is assumed 10 or 1, what is the value of the resistance? Maximum or minimum? Maximum or minimum?
Maximum.
Maximum. Okay, again I'm telling you, this is the curve for the photoconductive cell drawn between illumination and resistance factor. Suppose if the illumination is very, very low, this is a low range of illumination, light intensity very low, means resistance will be max. But on the other hand, here the light intensity is 10,000, but if you see to the resistance is almost very low. Okay, here it is minimum. Alright, this value of resistance is called as dark resistance. So this is showing a linear variation of resistance with respect to the light intensity. Okay, so this is all about photoconductive cell. This is also an electro-optic transducer. And next comes your photovoltaic cell or solar cell. This is an easy thing. You know that sunlight is composed of 3 different lights. One is visible light, another one is infrared light, and another one is ultraviolet. So suppose if you are using a PV cell, it will be converting visible light into DC, which will be used for electric power application. Now how that is being done is, it is converting sunlight to electrical energy. So this cell will be exposed to sunlight, because of which this is also similar to a PN junction diode only. So sunlight falls on this device. Okay. So what will happen? The electrons will try to jump to the conduction state. Okay. And in that excited state, they will try to move. All right. The electrons that are jumping to the conduction band, they will move freely. When these electrons are moving freely, then it will be resulting in the electricity. This is how a light energy is being converted into an electric current via a solar cell, or otherwise called as a photovoltaic cell. So this is one example application where you will be using a photovoltaic cell or solar cell for powering up a DC LED. Okay. All right. Or otherwise, some other applications if you see means solar water heater, that is used to give water based upon the sunlight that is falling onto the solar cell. So many different applications are possible for a solar cell, but basically it is an electro-optical transducer which converts the input sunlight falling on it, visible light especially, into an equivalent electric current. Next is infrared emitter. This infrared emitter is a special type of what actually? This picture is showing what type of electro-optical transducer. What is the symbolic representation resembling?
I'm not understood the question.
What is this device representing? That pictorial representation figure.
LED.
LED. Okay, so this is an LED. All right, light emitting diode only. So we are going to talk about infrared LED. So you have to use a special type of material that will be emitting only infrared range. Okay, which is not visible to you. It is an invisible form of light. So it is a special type of LED only, which is emitting out a special type of infrared light, which is not visible to you actually. And this will be taking place in the similar manner that LED is activated. This will be converting electric current into light energy actually. So how that happens is when the electrons are moving from or falling from the conduction band, they will be emitting out light in the form of photons when they are being forward biased. So this is how the action happens. But the important thing that is represented here, we are having several types of LEDs. But if you are picking one particular material with the help of which you want to get an infrared light, then you have to use that particular material. Or otherwise it will be emitting red light or green color light or any other color light. Okay. But that material, I think I have given in the list last class, one particular material, I think the name of the material I forgot. If you use that material for the manufacture of this LED, it will be able to emit IR light. Okay, it is an invisible light. And then how that happens is similar to that LED action. When you are giving electric supply to the LED, the electrons will fall off from the conduction band. And while they are falling off, they will be emitting light in the form of photons, which is visible light. Okay, so this is electro-optical transducer, which is converting what to what energy? This is an infrared LED. So what electric to
light.
Light. Okay.
And aluminum gallium arsenide is used.
Yeah, okay. So optocoupler is another important type of electro-optical transducer. The name itself is given by different versions. It can also be called as a photocoupler or an optical isolator or opto-isolator or it's a coupler, you will see. So if you see to this diagram, in the input side you are having an LED. Okay, this is an LED. In the output side here it is showing a phototransistor. Okay, both you are going to combine. Where you want to use this optocoupler or opto-isolator is in this side if you are having a circuit number 1. In this side you are having circuit number 2. Suppose if this circuit is low voltage and this circuit is high voltage, you cannot connect these two circuits directly. Alright. it will not work out properly. So you want an optocoupler or opto-isolator in between. Otherwise, suppose if you want to separate up one particular circuit from a noisy circuit, then for all these applications, you can make use of an optocoupler or an opto-isolator or photocoupler or optocoupler. All right. So where are you going to use this opto-isolator? Why do you need to have an opto-isolator or optocoupler? Where do you need to use an optocoupler or an opto-isolator?
Ma'am, to isolate a circuit.
Yes, to isolate not only a circuit, two circuits which are quite differing in their properties. So, for example, if one circuit is of low voltage, another circuit is of high voltage, you cannot connect them directly. You have to use what in between?
Optocoupler.
Optocoupler or opto-isolator. Suppose if you want to isolate one circuit number 2 from a highly noisy circuit, okay, for all these applications, you have to make use of an optocoupler or opto-isolator. Inside the opto-isolator, you will be having what two?
Opto.
Input side, you will be having LED. Okay, it will not vary, but output side, you can have a variation here. Here it is showing photo transistor. Okay, this is a photo transistor. Similarly, you can also use a photodiode.
Ma'am, what is noisy circuit?
Noisy circuit means suppose if you assume your single phase AC supplies of what frequency?
230 volts and 50 hertz.
50 hertz. Okay, suppose if the output that is coming out is not belonging to 50 hertz, it is having some other frequency superimposed on that signal. Okay, then some small amount of hum you will hear out.
Okay.
Have you seen that hum sound? Noise, so many different types of noises are there. Okay, you should not have that unwanted frequency component mixed into the wanted component. So those components will be called as noise components in general. There
So
are
the frequency will be increased or decreased.
It's not that increase or decrease. I'm telling you, no. There are so many reasons for the generation of noise. There is a white noise. So many noises are there that you will be detailedly studying in electron devices components only. I am giving you a small example. All right.
Okay,
By
ma'am.
taking a single phase AC supply means standard frequency should be 50 hertz. It should not be mixed with any other frequency. If it is mixed with any other frequency means you will be calling it as harmonics. Okay, that is
Okay, ma'am.
also some sort of noise. Okay, it will result in some small amount of hum if it is unwanted component. Okay, so not only hum, even you cannot hear the noise, but still it will be called as a noise. That causes for noise are different and the different types of noises are available. Okay,
Okay, ma'am.
so in the input side you are going to use an LED assembly. Output side you can have a phototransistor or a photodiode. Anything is possible. Accordingly, the type of optocouplers will vary. Okay, so LED, how it operates, you know. What is the use of an IR LED? When it is being given supply, it will be emitting IR light. That IR light will be captured by the phototransistor and then it will be connecting this input to the output circuit. This is how that signal transfer happens without actual physical contact between the two circuits. Okay, by using what arrangement in between? What is the name of this? What is the name of this electroacoustic transducer? Sorry, electro-optical transducer. What is the name?
Optocoupler.
Optocoupler or opto-isolator. As I told you, here you are using phototransistor. Similarly, you can also make use of photodiode. That is also possible. All right. So here you can use a photodiode like that. Okay. Accordingly, different types of optocouplers are possible. So if you are using a phototransistor means optocoupler with phototransistor. If you are using a track or if you are using a photo SCR, if you are using a photodiode, different types of optocouplers are possible. Okay, so this finishes off all the types of electro-optical transducers. So what are the various electro-optical transducers we have studied? Just list it out now. Just to give the names of all the electro-optical transducers we have discussed so far. Some names can be LED, then
LDR,
IR LED, then LDR, then solar cell or photoconductive cell. Then what else?
optocoupler,
Optocoupler, then so many we have discussed now. Photo diode, photo transistor, then photo resistor, photoconductive cell. Okay, photoconductive cell. And one more diode we have discussed, that is called as what diode? Laser diode. All these are belonging to what category of transducers? These are coming under electro-optical type of transducers. Some might convert electrical to optical or optical to electrical. That is light energy to electrical energy or electrical energy to light energy. All these will come under electro-optical transducer only. Okay, so this finishes off this category. Next class we will discuss thermocouple, RTD, that is resistance temperature detector. Those are coming under temperature transducers. That will cover up in our next class. Okay, with this we will wind up the class. Okay, let me check out who are present in class. Okay, all of you to leave now. I'm hoping all understood electro-optical transducer. Somebody
ma'am.
press that stop recording button.